Hey everybody, welcome to the video. Let's talk about using the computer to solve a system of equations for you. Now this is not particular to any specific application, nor even a discipline. You could be doing a physics problem or chemistry, civil, electrical, mechanical engineering. You do a bunch of stuff and then you have some math to solve, like this system of 3 equations for 3 unknowns. And how to use the computer to solve that for you. And you should practice solving it by hand just so that you're good at it and you know how to do it. But when you're at work, you would not do that. You would just use the computer. You wouldn't even use a calculator. Like you would use a computer. So let's talk about that in this video. I basically just skimmed through the book to look for something with a system of equations and the answers. So this is not specifically about the mesh current method as it says here, if you don't already know how to do that. But if you do, you can go ahead and maybe pause the video, give this problem a try up until you get to here. Now, what do we do with this? And the answer is turn it into its matrix form. Okay, so let me zoom in a bit here. Okay, let's focus our attention on these 3 equations. So let's write it in matrix form. So it's 3 equations, 3 unknowns. So it's going to be basically a 3 by 3 matrix times a 3 vector equals another 3 vector. And here it goes. First equation, 10IA minus 8IB plus 0IC equals 40. Okay. Second equation, minus 8IA plus 20IB minus 6IC equals 0. Okay. Third equation is going to be the third row, 0IA minus 6IB plus 10IC equals negative 20. So here we go. Here's a matrix equation to feed to the computer. How do you do that? I would recommend something like Matlab, industry standard. It's probable you'll use it at work, but you have to pay for a license. So a free open source alternative, Octave. And I recommend you download it, install it, and give it a try so that you gain that experience. Okay, so let me set this up. So this is matrix A, let's call it, times vector x of unknowns, these are what we're after, equals some other vector b. Right, so we have this matrix equation, a times x equals b. Solve for x. So how do you do it? Pre-multiply both sides of the equation by the inverse of a. This turns into the identity matrix, which is kind of like saying it turns into 1. And so you're left with solving the inverse of a times b. Right, so now let's do this on Octave. Let me open up the software and move my windows around. Okay, I opened up Octave. Now let's get this matrix equation in the software. So let's start with writing out matrix A. A equals, then in square brackets, first row, 10 space minus 8 space 0. And let me see if I can make this bigger. Okay, and then to go to the second row, semicolon. So now second row, minus 8 space 20 space negative 6, semicolon to go to the third row, 0 space negative 6 space 10. Okay, so let's say if I just run it, like see this is the matrix here. It looks like this. Okay, now let me type out vector b. B equals square brackets. So first row, 40. Now we already have to go to the next row. So semicolon, 0, semicolon to go to the third row, negative 20. Okay, so there's vector b. Now we want to do the inverse of a times b. How do we do that? Let's ask. Okay, so it's the help file says use the inv command to take the inverse, which is how you solve an equation that looks like this. A times x equals b, right? To do inverse of a times b, but then it also says don't do that, right? It's best to avoid calculating the inverse directly. Instead, use this syntax, which is basically an algorithmically more efficient manner to solve a system of equations. So I just literally copied and pasted that. All right, so let's run it. And here is our answer. And the answer from the book we were expecting, 5.6, 2.0, negative 0.8. So matches up. Okay, so I encourage you to try this for yourself so that you can gain that experience, put it on your resume, right? Win-win. Okay, so thanks for watching. I'll see you in the next video.